Hello, friends. Very good morning. We are here for a quick revision of these topics that are the two very most important topics that comes in our math, that is numbers and geometry. Usually, topic that children feel that it's very easy, know it all. Because of that, it is the topic that remains most ignored topic. But at the same time, we also need to know that numbers carry a lot of weightage. So it's a very, very as well as it's a very easy in concepts to understand. So in today's this short crash course, we are going to focus only on numbers. What exactly comes under numbers and geometry? Let's topics and start and see now. I'm going to take you through my presentation. In this presentation, you will get to see all the concepts that are numbers and geometry, along with the formulae and the example questions that are solved. So firstly, what are numbers? In numbers, natural numbers, prime numbers, squares and square roots, cubes and cube roots. These are the different types of numbers that are asked in your exam. On sorting of prime numbers, you may get a question square root, cubes and cube roots, sometimes a sequence number which follows a particular pattern of prime numbers, squares or cube numbers. So let's explore that further with an exam style question. So here are few number cards on screen. Use the number cards on the screen to answer the following questions. From the number cards, you have to pick up a few numbers which will follow the given conditions. Prime number. Then you also have to pick up a multiple of square number, a factor of 56. So if you are here sitting with me and solving the number questions, you can quickly answer them in your book. I'll wait for 2 minutes and then I'll explore as well. So here a prime number from the list could be 17. There is number, so you can write any one out of 7. A multiple of 3 is 21, which was given here on the list. A multiple of 3 could be 9 as well, but I have picked up 21 and written. You can choose any one number from the list and write. A square number over here and factor of 57. Now, type of question could come in your numbers is they will give you a number, they would ask you to express is as a factor of its prime numbers. So to know that, you all have to first know your prime numbers and have to factorize the given number. So that is another important as a question. And using these prime numbers, further what you can do is you can find numbers. Okay, so how to find the HCM is given here, is explained here with one finding LCM of 24 and 36 and finding HCF of 24 and 36. So for finding the LCM, the first step that we do is we prime factorize the number. Prime factorize the number we just now saw in our previous example question. So this is how we prime factorize them, and after them we write down all the prime factors to get the LCM, and we find out only the common factor to get the HCF. If you want to know LCM in detail, you can always scroll through my different videos of HCF and LCM and you can get a detailed explanation. In numbers concept, what comes most commonly is sorting of numbers in your exams would come. Other thing that comes most commonly is, and third thing comes main LCM and HCF. So if you of these three different things, you are definitely going to be able to answer such questions in your exams. Let's could be the other topics as a part of your exam questions is integers. Most important concept in numbers is integers, because no matter whether you do percentage, ratio, algebra, everywhere the rules of integers, especially the rules of addition, subtraction, very important. So here are on my screen, you can see that, and the rules are explained with one example questions. Let's study that in detail. both positive integers. So when there are both positive, we add them and write the number as it is. Then what if there is one integer positive and one integer minus 15? Minus 15 will consider as, and when you have one negative integer, you have to subtract the number and give the sign of a greater number. Third rule of integers, where both the numbers are negative. In negative, we add the integers and give negative sign to it. Then first integer is positive, then from that we are subtracting a negative integer. Integer, just because there are two negative signs next to each other, they make it positive, and then the final answer comes a positive. Again, we have to follow the rule that subtract and give the sign of a greater number. So in the example question where I have written negative 9 plus number 15 is the greater number. So these are quick rules of revision, addition and subtraction. Then a recap with, we'll move integers. So when you multiply two positive integers, your answer is positive. When you multiply two negative integers, positive. But if in case you multiply negative integer with a positive integer, then the answer is negative. No matter what is the sign of the greater number, whether the number is negative or a smaller number is negative, irrespective of multiplying, even one of the integers is negative, the whole answer is negative. So basically, two negative integers multiply and give you a positive answer. One negative integer multiply and give you a negative answer. Same rules are followed in case of division as well. Two positive integers divide and give one negative, one positive will give negative answer. So this is what the rules of multiplication and division are. After the rules of multiplication and division, as bird mass. So when we do bird mass, first we have to solve the brackets, then the orders. Orders means if any indices or square roots or cube roots are there, then it is called, it's brackets, orders, division, multiplication, addition and subtraction. This is the sequence when we are solving mathematical operations. So here 3 multiplied by 3 plus 7 minus 4 square divided by 2. So as per the rule, you can see bracket. So that is solved first. Then comes square of 4, which is 16. That's solved on the second step. Then 3 multiplied by 10 will be the third step, because there is multiple division has happened simultaneously. I have done that in one step only. And then the final answer is 30 minus 8, which is equal to 20. The mistake with is that when they are solving one particular mathematical operation in order of operations, they only write the rest of the maths operations on the solving, and then ultimately they give the final answer, but the rest of the things which you are even not at particular step, you need to know that you have to carry forward it down, note it down as it is. You may not solve it, but you cannot just leave them and work only on one specific concept you're working with. You have to have written all your steps, write all your mathematical operation, and then solve one at a time in each step. So that is what is highly recommended solving the order of operation questions. May also contain something like order of operations itself, but something very interesting, like insert a pair of brackets, statement true. Now over here, answer that is probably expected after solving order of operations. But how would that answer come? You have to place certain numbers and then based on that your answer is 17. So where exactly you would place those brackets is what your challenge questions are, and these are most often asked. We'll focus now on that. So here is an example question to you. If you are here live with me and if you're trying to solve the answer for this question is we have to write the brackets in 6 plus 5. So when we insert the brackets on the two numbers 6 plus 5, the next answer is going to be 11 because we have to solve the brackets first. Multiplied by 11 will give me 33 minus 2 multiplied by 8. That's going to give the answer as 16. The answer is 33 minus 16, which is equal to 16. If you have got this answer correct, well done, students. We will move next to the next question. Another important concept that comes as your numbers questions is rounding of numbers. So here for rounding. Now, when I'm talking about rounding, rounding comes as rounding of decimal place, whole number, significant figures, nearest 10. Rounding questions that can come as. So the given number is round the number 178.125 to nearest two decimal place, significant figures, nearest tens, nearest. These are the answers. So when you are rounding the number to two decimal place, you have to take in consideration the first two numbers that are mandatory for you to write. Because after decimal is what your rounding is. But what would be the last number? That last number's fate is decided by third number decides whether the second number or it will not increase by one. Is 5 or more. So my previous number, that is 2, has increased with 1 and it has become 13. Place is 178.13. Sorry. Same rule we have to follow when we do rounding to one decimal place. The first number after decimal and then the second number after decimal decides whether it will increase by 1 or not. Here, the second number after decimal is 2, which is smaller than 5. So, first number has not increased by 1. Then, three significant figures. Now, whenever significant figures rounding comes, the significant figures means you have to take in consideration the number before 8. After that, the decimal part starts. But the first number 5, so 178 remained unaffected, and the rounding to three significant figure answer is 170. Whereas tens to 178 is 180, so I rounded that number. 100 number to 178 is 200, and that's why the number is rounded to 200. So your rounding questions are going to be. Next concept after that in numbers is fractions. What exactly you have to learn and study in fractions is fractions improper and vice versa. Simplifying fractions, that is fraction to the lowest terms. In fractions, you also have to study equivalent fractions, arranging fractions in ascending and descending order, addition, subtraction, multiplication, and division of. So these are the few concepts in fraction study. Let's revise and recall each of them with one example question. So here on my I have converted a mixed number proper fraction, and then an improper fraction converted to mixed number. So when you convert a mixed number to an improper fraction, the given mixed number, the number multiplies with the whole number, and then you have to add the numerator. So that's the step that we follow for writing mixed. And then comes the improper fraction. So the improper fraction given here is 7 upon 3. We divide 7 with 3 the way we usually after dividing a number as something as a remainder. So when you are done with your quotient and remainder, your quotient is the whole number. That is why we decide the remainder takes part in the numerator. Number which with you have divided, the dividend that comes as a denominator. So how do you convert an improper? And simply note down a formula that indicates you the positions of quotient, remainder, and dividend. Make a note of this in your book if you're yet not done with that. Then we will move further to the next concept. The next is fractions to their equivalent. It's a concept of equivalent fractions. Equivalent fractions means the fractions will have the same reduced to the lowest term. So over here, a part of a shape is shaded, and the part to the total number of parts over here as 1 upon 3, and 1 equivalent to which of the three fractions that are given there on the screen is what my question is. And then the answer is 3 upon 7. 3 upon 7 equivalent to which fraction? That is the question. So if you want to take a while, 2 minutes, if you want to spend solving this, try solving this, and then the answer as well. So the fraction that was equivalent shaded fraction was 2 upon 6, because the shaded fraction there is 1 upon 3. There is one part out of the 3, and then 1 multiplied by 2 gives me 6. So 2 upon 6 is the fraction that is equivalent to 1 upon 3, and 3 equivalent to 9 upon 20. 3 times 3 will be 9, and 7 times 3 will be 21. And when I will simplify 9 upon 21 upon 7, that is why these two fractions are the equivalent fractions. If you have got your answer correct, well done, students. Next concept, and subtraction of fractions. So for addition and subtraction of fractions, if you have a fraction with a very easy, you keep the denominator same and add numerators. But what if the denominators are different? The case in which the denominators are different, what you have to do is you have to equalize the denominator. You have to find the LCM of the denominator numbers, and multiply the number with the possible number to make the denominators same. So here the example question on your screen reads 3 divided by 5, and 7 and 5 can be equalized by making them 35. So 7 times 5 will become 35. So be very careful that when you are multiplying your denominator with 5, you also have to multiply your numerator with 5. It because to maintain the fractions equivalent. And then your denominator multiplies by 7, numerator multiplies by 7 as well. And after doing that, you get your final fractions, the equivalent fractions to 3 upon 7 and 2 upon 5 as 15 divided by 35 plus 14 divided by 35. And when you add them, you keep 35, and 15 plus 14 you have to add to make it 29. This is how an example question of fractions, addition and subtraction will be solved. Since the procedure is the same, you have to equalize the denominator, but at the end the fractions you have to subtract. Question, that is fractions multiplication. When we are multiplying fractions, what we have to focus on, we have to focus on numerator with denominator. So here is an example question which reads 2 divided by 6 multiplied by 9 divided by 16, and you multiply 2 with 9, you get an answer 18. You multiply, you get an answer 96. And further 96 and 18, that is the fraction 18 upon 96, can be also simplified. So when you simplify that, firstly I have divided with 3 and I obtain a number 6 upon 32. And 6 and 32, since both of them are even numbers, we will divide them further with 2, and the final answer will be 3 upon 16. You can also do the fractions at the level. You can see my mouse pointer here, 2 and 6. You can simplify to make it 1 upon 3. And then the 3 over here, which you will obtain, you can add here with 9 as well. That is also another method. So whichever method you are comfortable solving with, you can use that method to simplify your fractions after multiplication. The next concept to multiplication is dividing fractions. How do we divide fractions? The first fraction we have to keep, flip the second fraction. Flip means reciprocal of the second fraction. That means the numerator will become the denominator. Fraction, you have to follow the steps that you have followed at the time of multiplication, that numerator multiplies numerator, denominator multiplies denominator, and then whatever answer you get at the end, you have to simplify that to get a fraction to its lowest term. So that's what how my dividing of fractions is going to look like. We are moving next now from division of fractions to another question. Fractions means here we have to compare the fractions, which fraction is greater and which fraction is smaller. So the commonmost and the simplemost method that we use for comparing fractions, multiplication method. Here the two example fractions given on your screen are 4 upon 7. The other one is 3 upon 5. When you're comparing them, what you have to do is you have to cross multiply. Cross multiply means the numerator of first fraction multiplies the numerator of the second fraction, and vice versa. When you multiply 4 with 5, you get an answer 20. When you multiply 7 and 3, you get an answer 21. Now compare which of that is a bigger number, whether 20, obviously 21 is a bigger number. That is why the second side, that is 3 upon 5, is a greater fraction, because the latter of the multiplication was a greater number. That is why the fraction that is latter is the greater number. Similarly, there is one more other example question given over here, wherein the previous multiplication is a greater number. That's why the previous fraction, or you can see the moving next clock, 24-hour clock. That's the concept of time. Concept of time, you get questions wherein you have to find the duration of the journey. You also get the questions of writing your clock time into 12-hour clock time and 12-hour clock time into 24-hour clock time. So the example question here reads, he starts at 5:18 p.m. Write this time using 24-hour clock. So it's 5:18 p.m. That's why I have to answer as 17.18 hours. That's my answer. Hours, how long the movie has, how long is the movie lasted? Calculate the duration. So end time, my students, all change I'll make here. Movie ends at 7:05 p.m. How long is the movie lasted? 7:05 p.m. converted to 24-hour clock is 19.5 hours, and converted over here in the 24-hour, which was 17.18 hours. And then what we have to do is, for finding the duration of any particular event, you always have to do the end time, start time. So end time here was 19.5, start time was 17:18, and that's why the answer is 1 hour 47 minutes. How I obtained the answer 1 hour 47 minutes? Again, you firstly write 19 hours and minutes. From that, you have to subtract hours and 18 minutes. While subtracting, we always subtract minutes from minutes and hours from hours. From 5 minutes, it's impossible to subtract. In order to do that subtraction, I have 1 hour into minutes. When I carry forward 1 hour into minutes, obviously 1 hour is equal to 60 minutes. So I 60 minutes here. Carried forward 16 minutes plus 5 minutes originally makes it 65 minutes, from which now I have to subtract 18 minutes. So 65 minutes minus the 18 minutes, my final answer is 47 minutes. This is the answer in minutes. What happened in the hours? From 19, I already subtracted 1 hour. That means 18 hours are left. And from the 18 hours, when you subtract 17 hours, the ultimate answer would be 1 hour. That's why the final answer there is correct while you were solving with me. Well done, students. The next important concept that we have to focus about is percentages. So express 24 as a percentage of 60 is the first example question that I have taken here. Expressing one quantity as a percentage of a quantity, when we are doing that, the number that is given first we have to write in the numerator. Expressing it as a percentage of 60. So whatever numbers percentage we are expressing, that you have to write it. And then numerator and denominator, since you are percentage, you will have to multiply it with 100. And then you will use the concept that you have already learned about multiplication of fractions to complete this percentage calculation. And when you simplify this as 40%. So expressing 24 as a percentage of 60, your final answer comes as 40%. Next question, in percentages and decrease. In percentage increase, if a particular question is given to you, you have been asked to find percentage increase. What you do, how you do increase, minus the old value or the old price divided by old price multiplied by 100. So these are the formulae we calculate percentage increase and decrease. If you are unaware of this, and if you want to make it down, a note into your book, rupees. Original percentage decrease. So when I calculate, I told you I will do old price minus new price. The cost decrease.